Today we will discuss Coulomb's law and some terms related with charge. First we will discuss Coulomb's law and we will discuss all the topics related to Coulomb's law in the chapter electric field and potential. So first we will take Coulomb's law. There are two types of electric charges, positive and negative. Like charges repel each other while unlike charges have mutual attraction. According to Coulomb's law, the magnitude of the electric force between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. The magnitude F of the force that one charge q1 exerts on another charge q2 at a distance r apart is given as F is equal to k q1 q2 upon r square. Here it is written as r. So it is r square in place of r. It is equation number 1. In SI system, k is equal to 1 upon 4 pi epsilon naught. Here epsilon naught is permittivity of free space in vacuum and its numerical value is 8.85 into 10 to the power minus 12 Coulomb square upon Newton meter square. Here k is constant and its value is 9 into 10 to the power 9 Newton meter square upon Coulomb square. This formula of Coulomb's law can be written in vector form as let a point charge q2 be situated at a vector distance r from a point charge q1 at the origin O. The force experienced by the charge q2 is equal to 1 upon 4 pi epsilon naught q1 q2 upon r square or r cap. It can be written as 1 upon 4 pi epsilon naught q1 q2 upon r cube multiplied by r vector. This is the equation number 2. Here r cap is equal to r vector upon magnitude of r is the unit vector along r. From figure you can see that O is the origin where point charge q1 is situated. At point P, point charge q2 is situated and the position vector from O to P is r. The force experienced by q2 by q1 is F and the force experienced by q1 by q2 is minus F. Figure shows that if F acts on q2 then minus F will act on q1 and the magnitude of each force is k q1 q2 upon r square. This is the equation number 3. So from Coulomb's law we can say that the magnitude of force between two charges is equal to the product of the charges divided by inversely proportional to the distance of between them. Unit of charge. In SI system, the unit of charge is Coulomb and it is denoted by C. So definition of 1 Coulomb is the amount of charge which flows through a cross section of a wire in 1 second if there is a steady current of 1 ampere in the wire. It means 1 Coulomb is equal to 1 ampere second. Another definition of Coulomb from Coulomb's law. So from Coulomb's law F is equal to k q1 q2 upon r square and we can write it F is equal to 9 into 10 to the power 9 q1 q2 upon r square. If we take q1 and q2 is 1 Coulomb and equal and r is equal to 1 meter, then F is equal to 9 into 10 to the power 9 Newton. It means amount of charge which when placed at a distance of 1 meter from each other in vacuum repels it with a force of 9 into 10 to the power 9 Newton, then it is a 1 Coulomb. So this is the alternative definition of the Coulomb's law. Now we will discuss most fundamental unit of charge. Most fundamental unit of charge is the magnitude of charge on an electron, which is denoted by E. So E is equal to 1.60 21733 into 10 to the power minus 19 Coulomb. The charge on an electron is minus E and on a proton is plus E. So 1 Coulomb represents the magnitude of the total charge on 6 into 10 to the power 18 electrons. It means 6 into 10 to the power 18 electrons pass through a cross section of wire per second due to a current of 1 ampere. Typical value of charge range from 10 to the power minus Coulomb, 9 Coulomb to 10 to the power minus 6 Coulomb. Hence, the nanocoulomb and microcoulomb are used in measurements. Now, we will discuss quantization of charge. What is the quantization of charge? The charge on an object is always an integral multiple of charge E. Charge on an electron 1.6 into 10 to the power minus 19 Coulomb. It means total charge Q is equal to Ne, where N is equal to plus minus 1, plus minus 2 and so on. This property of charge is called quantization of charge. E is the smallest unit of charge and is called elementary charge. The charge is additive. It means the total charge on a body is the algebraic sum of the charges at different parts of the body. Another topic which will be discussed is conservation of charge. The total amount of charge in an isolated system is always constant. The charge may be transferred from one part of the system to another part, but the net charge will remain the same. So the charge can neither be created nor it can be destroyed. This is called law of conservation of charge. Law of conservation of charge is supported by many examples, and some of them as follows. First, when we rub a glass rod with silk, a positive charge is obtained on the glass rod, and at the same time an equal negative charge is acquired by the silk. So this proves the law of conservation of charge. Experimentally, in another example, a gamma ray photon may produce a pair of electron and positron. Here also the net charge is 0 before and after the process. So in this video we have discussed Coulomb's law and definition of Coulomb and some property related to charge such as quantization of charge and most fundamental unit of charge. Thanks.